Thank you. Good morning. Well, good afternoon now. I'm here to talk to you about scaling and HA MySQL learnings. MySQL is now just over 23 years old. I presume all of you have used MySQL to some extent, maybe an older version. MySQL just released 8.0 in April, late April, and MariaDB just released 10.3 in late May. So 23 years of MySQL. There's lots of things one can learn about, do. And I think if there's one good takeaway from today is that the internet may not always be accurate. Things change over time, and there are always new best practices that evolve as we move along. So I work at Percona, and we make MySQL, a Percona server for MySQL, as well as we make Percona server for MongoDB. We do lots of support around MariaDB server, Percona server, MySQL. We make lots of open source tools. And we just announced that as of June, we will start also doing Postgres support. We're not going to do a Postgres server, but we are definitely going to make tools around it like we've always done. And before that, I was on the founding team of MariaDB server, and before that, MySQL. These slides are fully under the Creative Commons, so you could totally make use of them. They'll be available online later as well. So, MySQL 5.5 spawned two variants, Percona Server 5.5 as well as MariaDB 5.5. And then following that, MySQL 5.6 and 5.7 as well as 8.0 have only spawned a Percona Server variant, which is meant to be a branch that's better for observability, manageability, and higher performance. Now, for completeness, MariaDB 10.0, 10.1, 10.2, as well as 10.3 are based on the MariaDB 5.5 base, but it adds other features, so it cherry picks features from MySQL. So for all intents and purposes, MariaDB is supposed to be kind of compatible to MySQL, but not necessarily fully. So good examples would be MySQL 5.6 introduced something called time-delayed replication, which means that you could have a replica that is delayed maybe by 2 hours, 4 hours. So if you're doing live pushes, this kind of thing can make sense. So in case someone makes a mistake to the schema, you can always roll back without having to roll back the entire database, just point to a delayed replica. However, that sort of feature only came to MariaDB Server 10.2. And there was quite a big gap in terms of timing. So one was released in 2013, and 10.2 was released in 2017. Also things like streaming binary log backups. When you want to do automatic failovers or provisioning new new slaves, that also basically only came to MariaDB 10.2, but was present in MySQL 5.6. So it's probably important to note what MySQL or MariaDB you end up using, because many Linux distributions, with the exception of Ubuntu, is shipping MariaDB as your default MySQL. So typically, if you use CentOS 7 or RHEL 7, you've got MariaDB 5.5. And MySQL and MariaDB are quite different nowadays. So what is high availability? Largely, it has a lot to do with gaining good performance, but at the same time, also being scalable. And we tend to measure scalability in the MySQL world via throughput. We do that via transactions per second. If you come from a more commercial database world, you may think of transactions per minute, but we go down to seconds, typically. Latency is something else that is well worth looking at, and this is response time, and we measure this in percentiles. MySQL, if you use InnoDB, is an ACID-compliant database. How many of you here do not use InnoDB? Okay, so you don't. What do you use? Oh, but you XtraDB. Okay, yeah, XtraDB is a drop-in replacement for InnoDB. Okay, excellent. So, since 5.5, InnoDB has been the default default storage engine for MySQL. So it is such that you have ACID compliance out of default. The D in ACID is durability. And this basically means you never ever lose commit data. So the other ways to also ensure you are durable when you're thinking about a high availability stack is that you may also think of replicas. So you don't only have one slave, you have multiple slaves or replicas. You may also think of snapshots. So maybe you make snapshots of said replicas, maybe via the MySQL binlog utility. Maybe you also think about point-in-time recovery as well as backups via something like Percona extra backup, so you can get backups, whereas MySQL dump will give you more logical backup. You can get point-in-time backups with Percona extra backup. And then you also think about it from a replication standpoint to ensure that you have redundancy. And then from a clustering standpoint, and not to be confused with MySQL NDB cluster, you also think about monitoring as well as recovery and failover time. Failover time is definitely something that's extremely important. And the whole purpose of having a high availability stack is to ensure that you have no single point of failure. Being 23 years old, we have many, many solutions out there. So, of course, you've got stock MySQL, which with the 8.0 release has created something called MySQL InnoDB cluster that comes with group replication and a few other fancy bells and whistles. You've got Percona server, which has XtraDB and a whole bunch of other things. And you've got MariaDB, which comes now built in with Galera Cluster as well. Then you've got Percona XDB cluster with tons of engineering going behind it to make it a better Galera, a more stable Galera. You've got things like DRBD, which allows you to have synchronous replication on the block layer itself, as opposed to using MySQL replication to use block layer replication on the Linux side. You've got things like Tungsten Replicator, several lines of something called cluster control. We'll talk a bit about the Percona toolkit tools that could be handy. DB deployer, which previously was MySQL Sandbox, and the Spider storage engine, which allows you to shard your data using SQL, now included as part of MariaDB 10.3. So you can shard and reshard your data with the vertical partitioning storage engine. And sharding your data is part of how you become scalable in the MySQL world. You can't store all your data effectively on just one instance. You'll probably have to shard your data either via users, n number of users, maybe 400 users per shard, or you will shard them based on locality and so forth. And the other caveat of sharding, the sharding part is easy, the resharding part is the hard part, where you need to actually rebalance users. Maybe there's 5% of users on one shard are extremely active, and they need to be rebalanced to another shard. And resharding is something that we need to think a lot more about. So when it comes to uptime, everyone wants 5 nines uptimes. So they believe that you should never be down any longer than 5 minutes in a whole year. Now, how many of you actually achieve 5 nines uptimes? For sure? Yep. Measured? Okay. So a lot of people believe that, yes, 5 nines is excellent, but Pingdom, anybody here use Pingdom? Okay, so Pingdom releases statistics from time to time because lots of people tend to use them. And even here, there are a fraction of people that do use them. And Pingdom actually says that, generally speaking, only a fraction get past 3 nines. A lot of people tend to have a lot of downtime. Not a lot of downtime, a reasonable amount. 3 nines is still just 8 hours of downtime per year, which is not even an hour of downtime per month. When you deal with downtime at scale, you measure in the thousands of hours because a simple failure does not trigger ops to come back because there should be a replicated copy of the data serving just fine. And you may already have an automated solution to promote a failed master, have a new slave being promoted to the new master state. So simple replication, be it asynchronous or should be giving you anywhere between 98 to 3 nines uptime. Using a SAN, which is definitely not a recommended solution for MySQL, should also give you about 3 nines of uptime. Not recommended because you don't gain much in terms of uptime, and you lose a lot in terms of cost. Using something like DRBD or MHA should give you also about 3 nines uptime, give or take. But with something like MHA and semisynchronous replication, you should be able to go up to 5 nines uptime. And using something like NDB cluster, commonly known as MySQL cluster, which is in the 7.x release phase, or Galera cluster or MySQL InnoDB cluster should also be able to give you 5 nines uptime. We won't talk much about NDB cluster today because it is got a very niche use case, typically in the telco spaces, and I'm willing to guess nobody here uses NDB cluster, generally speaking, anyway. HA is a lot about redundancy. You already think in HA for many other parts of your system as well. You have RAID for disks, because you want to ensure that even if a disk goes, you always got something else. You have clustering for your servers, because servers do go down. Many data center-like hardware you can buy today will have multiple redundant power supplies. It doesn't only come with just one. In fact, most 1U servers even come with more than one network interface card. And generally speaking, from a geographical standpoint, you can get a situation where your data center goes offline or is destroyed, and then you send computation to another data center. Now, typically, this translates to natural disasters, right? So a couple of years ago, downtown Manhattan in New York got flooded because of a massive hurricane that passed by. And that would mean that a bunch of services in New York stopped working. But that doesn't mean your services can stop working because you're probably losing money. Another personal example would be, I like to use an American Express card, and I landed in Seoul once, and it just wouldn't work. And it was not my card's fault. It was the fault of the fact that Samsung had a data center go up in flames. So for one whole week, the AMAX services in South Korea were down. And it had nothing to do with AMAX not being working, but it had to do with a data center going up in flames. And externally, that affected people who had a Samsung Smart TV. Your TVs were maybe a little dumber that day. And if you had the Samsung phones with the SChat service also stopped working. So as I mentioned earlier, durability is extremely important. Not only should you care about the data being stored on disk, you also need to care that the data is actually being written to disk. That means you actually call fsync each and every time a commit is made. Now, a lot of people try to make benchmarks by turning off fsync. This means your database is extremely fast, but it's also extremely unreliable. So making benchmarks via turning off fsync is definitely great for marketing, so benchmarking, but it's not good for actual benchmarking. Now, if you ever wanted to turn off fsync, I don't know how many of you have ever heard of a library called libeatmydata. So libeatmydata is a great way for you to run, say, the MySQL test suite, for example, because the MySQL test suite can take an hour to run, and also is very harsh on your SSDs. But if you run libeatmydata, it doesn't call fsync, and it speeds up everything maybe by even 10x to some extent. So of course, you don't run production environments with libeatmydata, but on Linux, this is packaged in most distributions, and highly useful for you if you wanted to ever test what it's like to run without fsync. Any application, really, without fsync. So we also need to ensure, as part of ACID, that it must be written in a transactional way to guarantee the atomicity, the crash safety, as well as the integrity of data. Now, calling fsync each and every time you make a commit is extremely expensive. This is why databases since MariaDB 5.3 and MySQL 5.6 have something known as group commit in the binary log. This basically means, and you don't have to turn this on, this just works by default. This basically means that you can turn on this option, sync binlog equals 1, InnoDB flush log at transaction commit equals 1. And if you have multiple parallel queries, so typically more than three running queries, you'll benefit from group commit in the binary log automatically because it actually commits it as one group, one fsync as opposed to, say, 3 fsyncs. HA is definitely harder for databases, largely because you need to make sure that not only your hardware resources are redundant, but your data is redundant as well. And you also want to ensure that your operations must continue uninterrupted. And HA is definitely not, oh, my service is down, I'd like to restore from a backup. That's not being highly available. You want to be offering uninterrupted services that are measured in percentiles that we talked about earlier. You never want to say, oh, I'll be down for the next few hours. That's insane. You lose money every second, possibly. Now, are there many Java developers in the room? No, wow. I'm impressed. So the Java people came up with this idea called client-side XA transactions, largely because JavaDB in the early days probably did not do replication. Now, this is a nice idea in theory, where your client writes to 2 independent but identical databases, but it's an extremely bad idea in production because you can get out-of-sync databases extremely quickly. So, nice idea, but not something you should totally do. This is, of course, not to be confused with server-side XA transactions, which are okay, unless you're using something like Galera Cluster. Server-side XA transactions are extremely important. So this is something you never should do, even today, even though they have libraries for it. So remember earlier what I said about how paradigms change. I think that's really the takeaway from today. I don't know how many of you are running, say, MySQL 5.5 or Percona Server 5.5. Is anybody still running 5.5? Okay, quite a handful of you. But paradigms have totally changed, right? So the InnoDB log file size, you set this. The larger you set it, the longer your recovery time. More than 10 years ago, Wikipedia themselves reported with a small amount of log files, 256 megs of logs, it would take them 40 minutes, but sometimes it would take 5 to 10 minutes. Now that's non-deterministic, right? How do you go from 5 to 10 minutes to 40 minutes to sometimes hours? And that's because log recovery involves the ability for you to actually need to find the checkpoint time because it has fuzzy checkpointing. Then you need to find a log sequence number. Then you got to scan the log files basically from the last checkpoint. And then you've got to see if there's already been applied to those pages or not. And if not, you have to perform operations in terms of applying changes to the buffer pool. So basically, your data locality, your size of logs, your buffer pool size, your dirty buffers during the crash of InnoDB all will play a role in terms of recovery time. This is just kind of awful because you want more predictability in your services. So Percona Server 5.5 actually did include something called InnoDB recovery stats. So it actually tells you what it's been doing and gives you more sort of a progress report. But today, I'd say paradigms have totally changed because you don't do this any longer. Nowadays, you have plenty of replicas lying around that even if you end up having a crash, it probably makes no difference because when the machine has crashed, you've taken it out of the cluster, so to speak, and there's something else that's taken over for you. So you don't have to worry about InnoDB recovery time any longer. But this was a big deal when 5.5 came out, and probably still a big deal during the 5.6 times. But nowadays, with the ability for you to provision in the cloud, the ability for you to have multiple redundant machines, nobody cares so much about recovery time anymore. So, as I mentioned earlier, there is the ability for you to have redundancy through shared storage. And SANs are extremely complex to operate. They're extremely expensive. This isn't the scale-out solution that we like to talk about in the MySQL world. This is a scale-up solution, so don't do this. There's also redundancy to disk replication. DRBD is described as RAID over Ethernet. And probably the only good reason for you to use DRBD today for MySQL and not trust MySQL's replication is because you were used to a SAN. DRBD could probably be still useful to you. However, if you think you cannot lose a transaction and semi-synchronous replication or even fully synchronous replication would not suffice for you, then maybe you could use DRBD still. But generally speaking, you have reduced single node performance when you are using DRBD. So there is a trade-off. You have higher average latencies, and there is one service out there that uses this. How many of you use AWS RDS? Okay, so not as many as I was expecting. Nobody likes the cloud here. Okay. So AWS RDS has this thing called a multi-AZ option, and they do make use of DRBD, but they don't give you a live replica. But because of DRBD, you'll actually pay 50% extra costs, but you have it's highly available, but it's not necessarily something that would actually be useful in terms of a read replica. And they're about the only people today that still use DRBD for MySQL. MySQL by itself has got good replication nowadays. Rhobased replication is excellent. And then don't forget the semi-synchronous as well as fully synchronous replication. So, redundancy through MySQL replication. We've got standard MySQL replication, which we'll talk about probably in the next slide or two. We've got something called Tungsten Replicator. This is an interesting piece of software that was once owned by a company called Continuant, purchased by VMware, spun out from VMware as Continuant, and is still around. Not sure how they keep on surviving. The technology was extremely useful back in the day. Today, it's probably the best use case is for you to do heterogeneous environment replication. So if you want to replicate between, say, MySQL and Oracle, and you don't want to pay for Golden Gate, Tungsten probably makes sense for you. And the version that you could use is Apache license as well. So they have an open source version, Apache license, and an enterprise version. The enterprise version helps you put stuff across multiple data centers. You probably don't need that. But generally speaking, yeah, Tungsten heterogeneous replication is probably its only good use case now. Then there's Galera Cluster and MySQL InnoDB Cluster, both of which we'll probably have plenty of slides for. And these are both based on a similar paper written out of a university in Portugal about how one could do fully synchronous replication with optimistic concurrency control and writing to basically InnoDB. There's also MySQL Cluster, NDB Cluster. As I said, again, not something we'll be focusing on because it's really a telco thing. Naturally speaking, with replication, your storage requirements are multiplied, but you have huge potential for scaling out. MySQL replication, for the longest time, has been statement-based generally. However, row-based became the default in 5.7, and going forward, we expect more and more people to only be interested in row-based replication as opposed to statement-based replication. Now, statement-based replication basically takes a statement you enter onto the master and then applies said statement again onto the slave or sets of slaves, and this could occasionally lead to inconsistencies, especially if you basically use things like the current user or use a function or you use a UDF and so forth. Now, for some reason, MariaDB has chosen to focus on using mixed mode replication by default. So yes, MySQL and MariaDB support statement, row, and mixed mode. So the default in MariaDB is mixed mode, and probably something you should change the moment you've configured MariaDB, switch it to row-based replication, because it's generally much better overall. MySQL replication is fully asynchronous by default. That means a master will get a commit, and then it will continue saying OK to receiving more commits and telling the application you could send more stuff over without guaranteeing that any slave has received this. Now, this is great because it's fast, it's easy to set up, but it's also bad because if the master happens to crash, you've lost data till the master comes back up again. So this means you're extremely reliant on said master. So you always want to ensure that the master basically ensures a slave has also received and processed it. This is where semi-synchronous comes into play. So semi-synchronous replication came in 5.5 as a plugin. It's gotten better in 5.7 because of a way you basically commit data to the storage engine. And then you've also got semi-sync again in 8.0. MariaDB 10.2 and 10.3 have a more modern semi-sync replication that matches what you find in 5.7 and 8.0 as well. So semi-synchronous replication is basically what powers the whole internet today. If you look at top 20 website listing, and if you look at them that run basically MySQL, you will be remiss to find out that pretty much all of them run MySQL with semi-sync replication turned on. This includes the Googles, the YouTubes, the Facebooks. Wikipedia, you can actually go and take a look-see at their infrastructure because Wikipedia tends to open up their infrastructure for anybody to see, and so forth. So large websites are powered by semi-sync overall. And of course, a lot of people like this idea that you can get fully synchronous replication. And fully synchronous replication is something that definitely is available via Galera Cluster or Percona XtraDB cluster. And it's also available via something new called MySQL InnoDB cluster, which alongside 8.0 will combine the likes of group replication, InnoDB as a storage backend, and then using something called MySQL SH for maintaining it, and then the MySQL Router for load balancing purposes. So this is also a fairly interesting tangent when it comes to high availability because you've got Oracle backing this thing called group replication and InnoDB cluster. You've got MariaDB backing Galera Cluster. And group replication will not work with MariaDB at all. But Galera Cluster does work with MySQL. So this leaves Percona server for MySQL 5.7 and 8.0 in a very interesting position because Percona is putting lots of money behind XtraDB cluster, which is Galera Cluster. But you can also continue using the group replication plugin with Percona server. So this is so Percona server is sitting in the middle that allows you to either use Galera or group replication, and it can also help you maybe migrate between the two. So as I mentioned earlier, semi-synchronous replication is really what powers the internet. And you realize that the enhanced semi-sync replication basically is a thread that performs a transaction commit on the master. It'll block after the commit is done and then wait until at least one semi-sync slave acknowledges that it has received all events of the transaction or until a timeout does occur. And if you are finding that there are too many timeouts occurring, the master can revert to asynchronous replication as well, and then resume when the slaves catch up. And at scale, back in 2014 already, Yoshinori Matsunobu, who is a DBA at Facebook, wrote how they use semi-sync in production. And again, it's no secret that Google runs semi-sync in production because they were actually the originators of the semi-synchronous patch to MySQL back in the 5.0 days. So if you look at the MySQL patches for Google, you'll find them. So replication in 5.6. And this is when I think replication started becoming extremely interesting and different. The reason why I've included 5.6 is because there's some things here that maybe MariaDB did not quite inherit as well. Global transaction IDs are extremely useful because it means that throughout your entire replication topology, each and every transaction is assigned a unique identifier for it. This would make automatic failovers very quick because you can just compare global transaction ID numbers and then just say, I'd like to replicate from this GTID number. In MySQL, but not MariaDB, you have this concept of a server UUID, unique user identifier. Every server in MySQL has this as well. The ability for you to do filtering, so you can ignore server IDs and have replication filters, exists as well. Multi-threaded slaves are on a per schema basis, so per database basis. MariaDB does this a little differently in the sense that they'll allow you on a per table basis, so a bit more granular. Group commit in the binary log is basically what allows MySQL to run in a ACID durable fashion today. Having binary log checksums, event checksums, are extremely useful because imagine if you were just replicating from master to slave, but you never actually checked to see if what you were receiving from the master was correct. Maybe you had corruption via the network card and so forth. If the checksum fails, this is a great reason why replication should stop. Because you should not be replicating garbage. Because if you replicate garbage and you need to do a failover, well, you've failed over to basically garbage. And that's not good. This is also very similar to people doing backups. So I don't know how many of you were around when a service called Magnolia used to exist. Magnolia was the competitor to Delicious. Now, Delicious is something you probably don't even remember because Yahoo bought them and then Yahoo sold them. Anything that goes to Yahoo, kind of. So maybe Pinboard is now the social bookmarking platform of choice. But Magnolia actually died largely because they were doing backups. They weren't running replication. They were running backups, not via MySQL dump or extra backup. They're running backups via syncing the data directory for MySQL to another machine. They thought they had a backup. But little did they know that their backup was garbage. So it didn't work for them. So yeah, don't rsync your data directory. Also, the binary log is now crash safe. I think this is extremely important because previously it would be stored in the data directory. Now it's part of an InnoDB table. Time delayed replication, again, very useful for everyone doing all these live pushes nowadays. And also parallel replication. So replication, start transaction with consistent snapshot. Now this is available in MySQL 5.7, Percona Server 5.6 and 7, and MariaDB 5.3 and greater. And basically, the enhancement allows you to make binary log positions consistent with InnoDB transaction snapshots. The feature is definitely useful if you're trying to obtain a logical backup with correct positions without having to run flush tables with read lock. The binary log position can then be obtained via several newly implemented status variables. Typically, they are binlog snapshot file and binlog snapshot position. So basically, after you start transaction with consistent snapshot, these two variables will now provide you the binary log position that was corresponding to the state of the database for the consistent snapshot to be taken, irrespective of which or any other transactions that have been committed to it after the snapshot was taken. And this actually has become a byproduct of group commit in the binary log. This also enables you to do MySQL dump single transaction master data, and you get a full non-blocking logical backup. And of course, this also works consistently between transactions involving more than one storage engine. Though typically, this is not something most people do because you tend to just run InnoDB. Though this is important because going forward, there are other storage engines. So MariaDB, of course, has the ARIA storage engine for temporary tables. Now has the MyRock storage engine generally available in 10.3. Percona server has also got TokuDB, like MariaDB has, as well as MyRock. So MyRock is probably a very hot engine because it's based on RocksDB. It's a log structured merge tree, and it allows you to do fast inserts and has great compression. And the reason why it'll probably be very hot is because pretty much all of Facebook runs on it now, as opposed to InnoDB. And that's where the ability to work consistently between more than one storage engine might make sense. Percona server has one additional improvement, such that you can also see session IDs, and then so you can actually just take a backup based on session IDs, and then you can also has backup locks, which is something that XtraDB has had by XtraDB and extra backup can make use of. So you don't have to make a large amount of backup. You can just backup lock. So, multi-source replication. This actually first came from Tungsten Replicator. Then it came to MariaDB server. It was contributed by Taobao Alibaba. And then it also came to MySQL 5.7. And of course, the syntax differences between the MySQL and MariaDB variant. And again, you need to generally think about using global transaction ID based master to multi-sources and binary log master to slave. This is typically extremely useful if you want to run real-time statistics across all your shards. You get multiple master shards writing to maybe one single instance. Maybe you want to make a complete backup. Multiple reasons why this might make sense. So global transaction IDs, of course, support multi-source replication. That's an important thing to have. Global transaction IDs can be enabled or disabled independently. In MariaDB, it's actually turned on by default, so you don't actually disable it. It's just appends it to the packet. Slaves using global transaction IDs obviously do not have to have bin logging enabled, though going forward, bin logging is something that everyone seems to turn on. And it's also worth noting that in 5.6 of MySQL, but not Percona Server 5.6, you actually had to shut down all your servers and restart them all at once to get global transaction IDs turned on. But Percona Server 5.6 is something called the step mode, so it'll allow you to turn on global transaction IDs while everything is turned on. MySQL 5.7 and 8.0 allow you to turn on global transaction IDs automatically. You don't have to restart your entire topology. And this is one of the reasons why MariaDB's global transaction ID differs from MySQL's. So in MySQL 5.6 global transaction ID, the implementation did not support multi-source replication, but 5.7 and greater does. The ability to have log slave updates equals 0 for space efficiency, so you didn't actually want to use more disk space, also available now in 5.7, but MariaDB had to go its own way. And then, of course, to turn it on without having to restart the entire topology, also like 5.7 and greater. So when MariaDB introduced global transaction IDs, 5.7 was not out yet. MariaDB was looking at what was available inside of 5.6 and realized that it would make a lot of sense to make a fork, so to speak, of global transaction IDs, design it differently. Now, the caveat to designing it differently is that now you have two competing global transaction ID standards. And if you're using software, so software like MySQL Router, the modern MySQL connectors, they all tend to rely on needing the MySQL global transaction ID. They will not work with MariaDB's global transaction ID. So even tools that I'll talk about later, like MHA, which can do automatic failover via two methods. One via doing a binary log diff, or the second method, which is the much quicker method, via global transaction IDs. MHA only supports GTID-based failover on MySQL, but not MariaDB. So this is one of those caveats when you decide to diverge with global transaction IDs. And having the ability to have the GTID in the OK packet is something that MySQL has, but MariaDB does not have yet, and it is in the plan for 10.4, is important because Proxy SQL, a proxy which we'll talk about soon, also makes use of the GTID in the OK packet for various things. So this is one of those reasons why it becomes important to start making sure you know what you're using as a base and then planning ahead based on the tools you're going to use. Parallel replication in the MariaDB world is run per table, not per database. Basically, if you have parallel replication turned on, in theory, your slave can be as fast as your master. It should be able to automatically detect non-conflicting row-based events by comparing primary keys and then executing them in parallel for you nowadays. MariaDB has something known as optimistic parallel replication. So if your master is running 10.1 and greater and your slave is also 10.1 and greater, it makes it basically makes the slave as fast as the master again, because it can apply stuff sequentially to the master. So parallel replication is extremely useful. Very good talks by Jean-François Garnier from Booking.com on comparing both implementations of parallel replication on his blog, typically. So sometimes the stuff gets out of sync, right? Because sometimes people write to the slave directly. So maybe you should always set read only equals 1. Sometimes people use statement-based replication. And it turns out that statement-based replication is terrible if you use triggers or stored procedures or have non-deterministic SQL. Sometimes people do crazy things like have their master in MyISM and the slave in NDB. I don't know why you do this, but we've seen production instances of people do this. And it's insane. This will cause deadlocks for you. Never do this. Sometimes people basically make their replication filters incorrectly. Sometimes you've got binary log corruption on the master for whatever reason, bad disk, bad memory on the master. Read buffer size is larger than max allowed packet. And then sometimes, you know what, you've encountered a replication bug. So you want to ensure your replicas are not basically garbage. Make sure you have some kind of replication monitoring in place. I think universally, everyone who uses MySQL in any serious fashion ends up using Percona toolkit. And it has maybe like 20 tools, but from a replication standpoint, the relevant ones are PT slave find, which will allow you to find your slave information from the master. This can help build up your replication topology. PT table checksum, which is a replication consistency check. It'll execute checksum queries on the master. And then, if it finds issues, you can then run PT table sync, which will synchronize the table data efficiently. But this actually changes your live data, so if you don't have reliable backups that you've tested can actually restore, I would not run PT table sync. In fact, it warns you that it's going to make changes to your live data, so make sure you have backups that can restore. We also realized that many people don't like command lines that often, so we made a GUI available for you. So GUI is based on Prometheus, Grafana, and a whole slew of other open source tools cobbled together to make Percona monitoring and management. And it comes with things beyond just replication monitoring. It also has query analytics with Spark lines, metrics monitors, and it's fully built on open source software. So because of the open source software that we had to inherit, I think it's licensed AGPL v3. And we highly recommend you to try it because it also comes bundled with Orchestrator, which we'll talk about soon. You may, if you're running MySQL binlog. Oh yeah, before I forget, there's also like a demo. You can totally test this out in your spare time. Like actually, we have a live running cluster of maybe 15 machines or something you can play with. So you may see errors like this, like error in log event, read log. It's found an invalid event in binary log data. And this is largely because it's likely your MySQL client does not agree with the MySQL that you have installed. So if you're using MySQL client from MariaDB, which also calls it MySQL client, you may suddenly realize you can't use it against MySQL server, which you get, say, from Oracle itself. It's largely because global transaction ID varies, and some features like streaming backup server did not exist previously as well. Slave prefetching. Everybody likes to ensure that when you create a new slave of some sort, you'd like to make sure that that slave is warm such that it can serve queries easily. And Percona server right up till 5.6, as well as MariaDB right up till 10.1, has something called InnoDB fake changes. And this basically prefetches threads to warm up the server. It replays statements, and then it rolls it back at commit, hence why it's called fake changes. So it reads rows for inserts, updates, and deletes, but it doesn't update them. And the rollback is extremely fast because there's nothing to do. And this ensures that if you had a 64 gigabyte slave that started off cold, it'd actually be fairly warm fairly quickly so that it can start actually serving queries as opposed to having to do it each and every time someone makes a query. But paradigms have changed. You don't need to have slave prefetching any longer. So Percona likes to remove features if possible. If it can't go upstream or if there's a better solution, features will get removed. So now you can do intra-schema parallel replication, and that's a great way to warm up your slaves. And MariaDB Server, of course, also removed it because they switched back to InnoDB. They decided to fork InnoDB further. Galera Cluster only works with a transactional storage engine like InnoDB. It does not work with MyRox, which is also transactional, or TokuDB. It replaces the MySQL replication layer, but can also work alongside it because it has something called the write-set replication layer. It is generally what I'd call a true multi-master active-active solution. We tend to call it virtually synchronous replication because while it is logically synchronous and the actual writing and committing to the table space happens independently, this also does naturally happen asynchronously on each node. It follows a quorum algorithm, so it needs a minimum of 3 nodes, because if one node goes away and you have 2, 50% does not make a majority. Its WAN performance compared to async or semi-sync replication is maybe a little slower. When I say WAN performance, this is basically your local area network. It is not something that we'd recommend you to run across data centers. You can run clusters of Galera across data centers, but not have your nodes separate into data centers. You, of course, again, have no slave lag or integrity issues. Node provisioning is fairly automatic. You can actually do self-discovery. And it does use optimistic concurrency control, so that, as I said earlier, transaction is done locally until commit time, then applied across all nodes in a basically asynchronous fashion. Codeship has been around for maybe 7 or 8 years now. And they were generally doing about 3 releases per year, but they've slowed down a lot, and we've been waiting for Galera Cluster 4.0 for over 3 years now. MariaDB has integrated Galera Cluster into MariaDB. So the write-set replication option is available for you inside of stock MariaDB. Percona has not integrated into Percona Server 5.7. It's still a separate download, but has other integrations. And there are plenty of users for Galera Cluster. We've had people migrate from Oracle RAC to Galera Cluster. We've had the DNS as a service for HP. OpenStack recommends it. People like PagerDuty, AVG, they all tend to use this. So it does have its users out there. Percona XtraDB cluster is basically Galera Cluster, but with engineering done within Percona. We bundle Proxy SQL. We have PMM exporters ready for you so you can integrate well with Percona monitoring and management. You, of course, benefit from the full MySQL 5.7 feature set. Also comes with a Proxy SQL administrator tool so you can administer Proxy SQL. And it has some safety features enabled, like we won't allow you to accidentally have a table type as MyISAM, for example, because that would just break. And it'll break silently, and we don't like that because then when you've lost data, you'll be screaming. Well worth checking this out as well. And the reason why Proxy SQL has to be embedded is because you need a minimum of 3 nodes, and having Proxy SQL on the front is important so that you can do load balancing, for example. And or if you start expanding the nodes behind it, you might want to only set a certain set of nodes to read, and a small set to write, and a large set to read, because you don't want to be having this hot row problem. Group replication is, as I said, very much like Galera. It's also got fully synchronous replication, basically update anywhere, self-healing, has elasticity, redundancy. By default now it's single primary mode, but you can of course configure this to have multiple. And of course it does use SSL. It's much newer than Galera Cluster, so we don't see much production use cases of this yet, but I fully expect that in the next 12 to 18 months, group replication is going to be very famous because it's clear that Oracle's putting lots of resources behind it. And with InnoDB cluster, you can actually have combination of group replication, router, MySQL SH, and you literally have, it takes less than 5 minutes to get your InnoDB cluster set up. And there is a video on YouTube. If you type MySQL InnoDB cluster on YouTube, you'll see Frederick Descamps give you a 5-minute video intro on how you can get this set up. in 5 minutes. So yeah, quick summaries. Generally speaking, replication is the way to go. I think semi-sync is, of course, a good option for most people. However, if you need the ability to never ever lose a transaction, then Galera and soon InnoDB cluster might make sense as well. When it comes to handling failure, you possibly do things like polling, monitoring, alerts. Also, you need to know after you've figured out what has happened to failure, what do you do about it? And then you have to make sure you've protected data integrity as well. And you want to ensure that you never have a situation with a split brain, right? So there are plenty of frameworks to handle failure. And I obviously won't talk to you about all of them. But again, your choice of database server is important. For one, this will not work with MariaDB. MySQL MHA, Global Transaction ID failover will only work with MySQL, and so forth. And Replication Manager. So again, while I don't have a slide for that dedicated to it, Replication Manager is basically a rewrite of MHA, but written in Go. MHA is written in Perl. Now, there's nothing wrong with MHA being written in Perl, and one could configure it, but someone decided maybe we would like one Go binary, and maybe throw on a little user interface. But there's no real gain over having said user interface beyond the fact that it's not Perl. Now, I have no problem with Perl, and most people in the MySQL will have no problem with Perl. So that's one of the reasons why MHA is probably a lot more utilized than, say, Replication Manager. Orchestrator is something that I highly recommend you to take a look at, because it reads replication topologies, keeps state, continuously polls, it's Apache 2 licensed, extremely well documented. It's a GitHub project. It started its life at Outbrain, then to Booking.com, and then became a GitHub project. It's also written in Go. It allows you to kill long-running queries, modify your topology so you can move slaves around. It's an excellent piece of software. Highly recommended for you to try this if you care about replication and high availability. And soon it'll also have built-in automatic failover, and it's learning a lot from MHA. So this is probably the tool that one would use in the next 12 months for automatic failovers as well. MHA does automated as well as manual failover. And why would you do a manual failover? Maybe you want to do a schema change. That would make a good reason to make a manual failover. And again, it chooses new masters by comparing slave binary log positions. This works for both MariaDB and MySQL. But as I said, GTID-based failover just on MySQL. Pacemaker comes with resource agents, right? So it's Percona Replication Manager is now inside of the Pacemaker resource agents. And again, you can use things like Heartbeat, CoreSync. I'd say it's extremely specialized, and we've seen instances where Pacemaker can also segfault. So while this is a great way from a Linux standpoint, it's probably not something that we recommend unless you have good Linux chops, so to speak. You also definitely need a load balancer. And your load balancer probably also needs to ensure it's not just one load balancer, but you have several. HA proxy is great if your database server supports the proxy protocol, and so far only Percona server 5.6 and 5.7 supports the proxy protocol, and MariaDB 10.3. You could use HA proxy, but HA proxy does not understand SQL. MaxScale and Proxy SQL definitely do, as does MySQL Router. MySQL Router is basically the application connections that will be transparently routed based on load balancing policy without ever implementing custom application code. This is part of that InnoDB cluster that I was talking about. And it can also distribute application connections in a round-robin fashion. I expect, again, in the next 12 to 18 months, this will be extremely popular, but maybe not today. MaxScale. MaxScale was the golden child in terms of routers, because it was the first that went GA. It was level 7 proxy router, understands the MySQL protocol. It's basically a Swiss Army knife, right? Because it's got a pluggable architecture, so you could do query level analysis, schema-based sharding, had a Kafka backend, and so forth. It was an excellent piece of kit until this licensing thing came about, in where it stopped becoming free software but became license under the business source license, which basically says you may use the license work with the application uses the license work with a total of less than 3 server instances for any purposes. So to start a useful cluster, you need 3 server instances, so you'd have to pay a license fee, which seems ridiculous. So this is now not the golden child anymore. The golden child probably is this, Proxy SQL. Largest deployments spans several hundred proxies. It's extremely high performance. It's written by DBAs, for DBAs. So it was written by Rene Canal during his time at Dropbox. He's not there anymore, but Dropbox is a whole bunch of other people. It does query writing. You can do shard by host schema. You can change rules and modify SQL without having to restart Proxy SQL. So again, written by DBAs, for DBAs. Definitely highly recommend you to check this out. You can also do high availability inside of the drivers. So most drivers nowadays, like JDBC, PHP, and stuff, can do read-write splitting, round robin, random host selection. Again, no single point of failure. Fully aware of MySQL transaction state and errors. This is definitely an option that not many people end up using. Is clustering a solution or part of the problem? So there's a white paper written called Causes of Downtime in Production MySQL Servers. Number 1 cause of downtime, human error. Okay, problem between the keyboard. Number 2 cause of downtime, using a SAN. So then some people think, why not do a clustering framework plus SAN? It turns out that'll give you even more problems, so avoid that. So in terms of replication types, I guess, you need to think a lot about your competencies. Like, are you a competent DBA? Are you a competent Linux sysadmin? And so forth. Those are definitely important thoughts to think about. If you are a competent Linux person, DRBD probably can make some sense to some extent. Statement-based versus row-based replication. So row-based replication is definitely deterministic. Statement-based, in my opinion, is extremely dangerous, so you should probably stop using it. Global transaction IDs are definitely easier to set up and fail over, and they can handle complex topologies today. Async is fast, but you'll have data loss and failover. Fully sync is the best, but it's also the slowest. So semi-sync is a good middle ground. And then multi-threaded slaves is something that's been around since 5.6 and greater as well. So I don't know if, since earlier, not many people said they use the Amazon RDS. I don't know how many maybe use Google Cloud SQL or not. But it's worth noting that scalability and HA tends to be built in via their GUIs. RDS has things like multi-AZ, but you don't get a read replica, so you still need to pay for that separately. Google Cloud SQL is actually the first of all the cloud providers to actually use semi-synchronous replication in production. So you actually get very, very fast failovers. You want to watch out for the SLAs because they also do automatic upgrades. Automatic upgrades, backups and stuff are not included as part of the SLA time. You want to monitor via performance schema tremendously. Also in the cloud, bad nodes exist. So have a certain set of queries you'd run. If you hit a bad node, kill the node, get another one. Now, I did not even get much time to talk to you about Vitas, which is another framework, sharding framework that allows you to shard, reshard, and at the same time act as a proxy. And Vitas is now governed by the Cloud Native Compute Foundation, and it started live at Google, actually. It is what powers YouTube. So if you look at YouTube, every time you go to YouTube, it is powered by Vitas, and Vitas makes use of lightweight binary BSON connections. So every connection is only 32 kilobytes in size, versus up to 3 megabytes with MySQL. Why did I not give a dedicated slide to Vitas? Largely because it's still got limited SQL, so it's not full MySQL parser. But because it's a CNCF project, it's being used at places like Slack and JD.com and a whole bunch of other places. I expect it has a very, very bright future as well. Replication is extremely amazing if you know how to use it and monitor it well. With global transaction IDs, you have great operational usability. Large sites just run fine with semi-synchronous replication. Don't forget the need for a load balancer like Proxy SQL. And when you're thinking scaling, think scale out, not scale up. So, with that, I'm pretty much out of time. So thank you for listening. If you have any questions, I'll be here for the next couple days. And if you have a question now, do I have time for like one question maybe?
I think for one question we have time.
Okay. Anybody have a question?
Okay. Yeah, thank you for your talk. I'm just curious about running the PT table checksum tool or the Percona toolkit on a production database. Is there any pitfalls doing that? So in terms of table locking or stuff?
PT table checksum running in production, will there be any pitfalls for any table locking? So no, not for PT table checksum. PT table checksum is not destructive. It is just basically there to ensure that there are checksums being run in a new separate table that creates. PT table sync can be destructive. So if you find that checksums are not matching, then and you need to sync it, that's when you need to worry. But PT table checksum is something a lot of people tend to just run without worrying about table locking.
Okay, thank you very much.
Thank you.